Let's start with novel deployment modes, and I would like to highlight something which may not be very obvious, but we are really migrating from a world which was very cell-centric to a world which is very user-centric. Cell-centric means, it was all about different base stations, and you as a user needed to make your bet essentially which base station you talk to, and once you made that bet, you essentially talk to an uplink and downlink to the very same base station. In this future 5G world, that will be very different because me as a user, I'm now seeing loads of base stations. Remember, we're increasing the density of the infrastructure. And even today, when you switch on your Wi-Fi, I mean, you see like 20 Wi-Fi access points. So we will have the same in cellular. And then it doesn't make sense to have, a very sales-centric approach. The user should decide, you know what, in uplink, I think it's better to talk to this base station here. And in downlink, I think it's better to get the signal from another base station. And we call that the uplink and downlink decoupling, which I personally also co-pioneered with my buddies in the field. So, that is the type of development we'll be seeing, a much more flexible, approach to the rollout, very, very much user-centric. Another exciting development is on the device to device. So device to device has been around for a while. We have been talking about this as previous releases. It's not new to 5G. But we believe that the way the control is handled, the way the anchoring is handled within release 15, that will be a very, very exciting opportunity to do a lot of the offloading, to support a lot of the vehicle-to-vehicle communication type of applications. So therefore, to go in an almost infrastructure-less deployment is very exciting. So the idea is essentially to have control from the base station side and then have the data plane being transmitted between two devices. You can use it, as I said, vehicular to vehicular. You can use it in crisis situations where there's a out of reach of the base station. Loads of opportunities with D to D. Let's talk applications. And before we do that, I want to quote a very smart man, Hans Vestberg. He's a former CEO of Ericsson and currently, as of the recording of that video, the chief executive of nonetheless and Verizon. So Hans said something very smart back then. He said, we started to design 3G when the internet wasn't even truly around. And we started to design 4G when the smartphone wasn't invented yet. Well, we interpolate that, and you may ask yourself, we have started to do 5G, but then when something was not around. I'll leave that to you to design, but just bearing that in mind that we may not want to get married to a very specific application today, but rather be open for that. Let's design this platform, which we call 5G, and very smart people will come up with something which will really use that infrastructure to the very last. In terms of application scenarios, 3GPP, NGMN, and ITU have spent a significant time of trying to understand what do we actually want and what are the key performance indicators. And that's well documented, so it's in TR 38913. And, the scenarios range from indoor hotspots, dense urban, rural, macro and high speed, as well as to highways, connected cars, light aircrafts even. So we have a wide range of different applications which need to be supported by our 5G system. Let's come now to the very exciting part, which is some early 5G trials. And I've been personally leading these, and I can tell you a lot about the methodology, the working methodology here. So one thing, I learned with my companies is that you can design the most beautiful technology. If your final customer does not understand what it is for, they will not be interested. They will just see that as a cost exercise. So I wanted to make sure that when 5G comes out into the market, the industry and the consumers would not perceive this as, well, yet another system where you have to pay a certain amount of money to use it. But I wanted them to be excited about it, to see the value of that. Because once people see the value, they will not question the cost. So I spend a lot of time with my team at King's College to reach out to different verticals, consumer groups. And you see a few images here. So we worked, for instance, with various theaters in London, and we worked with hospitals, with the transport industry, gaming, financial, sports, anything you want. And we did a very deep co-design. So this was not about sitting with them and just having a 1 hour PowerPoint about 5G. This is literally spending, hours, days, weeks, years with them. And an example is from the performing arts world. So we actually spend a good time trying to design a totally new play, which would be adapted to 5G technology, where we would have two theaters being connected in real time. We tried first to do Shakespeare. It didn't work because Shakespeare didn't write his pieces for 2 or 3 stages in mind. So we had to engage with very talented writers and to come up with a totally new stage play, which was adapted to that distributed setting. So that is the depth of engagement we had, and I encourage you to do the very same. And as a result of that, every single industry said, hey, you know what? I want 5G. When it comes out, I want it. I don't care what it costs because I see such a disruptive opportunity for my vertical. I really want to have it. So, and that's really where I wanted people to be. And I want to talk you through now some of these examples so you get a gist of what we have been doing. There's one on transport. So we did a very exciting one here, and that was world's first. So you see a drone here, which was a big industrial drone. It's quite big, it's a meter, a little bit more than a meter in diameter. And we had it flying in the courtyard of King's College in London. And there was a guy who was controlling the drone, and he used his remote control. And, typically the remote control would connect straight to the drone. Now, what we didn't tell him is that this time he was not directly connected to the drone. The remote control was connected to a 5G system, and that was sliced across the Atlantic to the Verizon network, came all the way back, and was controlling the drone then from the signal which came back. So the person didn't even know, he didn't even notice, right? So what we wanted to show really here is that we are able to control very critical processes from across the planet. It's a true internet capability. So this is not a closed control intranet, very close environment system. No, this is an internet. So imagine a crisis situation in the future where we have people in need in a flood area, and they need water, they need food, they need medicine. We can have the best drone controllers fly these drones, and they don't need to fly in. They can do it from their homes in New York, in Sydney, in Moscow, in Berlin, anywhere, from anywhere in the world, you can control them. We showed the world that this is possible with 5G. Another one, really exciting one, is on medicine. So let's first listen to this video here and pay attention what Professor Prokar Dasgupta is saying. Remember, he is a practicing surgeon. Let's listen to the video.
We need to disrupt the way we see medical treatment. If you see an open surgeon operating, they will have a bit of tremor at the ends of their scalpel. The robotic instruments are computerized, so they have absolutely no tremor. There is one problem though. There is no sense of touch at the end of the instruments. It is very difficult to transmit across remote distances and across current robotic systems. In order to do this with haptic feedback technology, you need two things. You need network slicing and you need cloud data share. I think both are possible through 5G. It also allows us to bring the best education internationally to the next generation of doctors. It gives us the opportunity to educate anyone, anywhere. Often we have to go to their hospitals, to their sites, to mentor them.
Isn't it amazing? This is, what a doctor said. I don't know if you know as much about, arteries and veins as he knows about, edge cloud and slicing. But with Prokar, we had a great engagement, and he happens to be, at King's College in London, a colleague of mine here, and he's a pioneer in robotic surgery. Why do we do robotic surgery? It is very slow, admittedly. So, doing the traditional way of, let's say, opening the patient and doing the surgery and closing the patient up again is much quicker. But robotic surgery is not so intrusive. So you're only left with a very small keyhole, which you barely see after the operation. And it is very precise. So you have almost no blood loss, which means that you can go home within 24 hours rather than 7 days or 14 days being in the hospital. And that's the business case for the hospitals. Now, why did we engage with Procca? Because he gave us free homeworks. The first thing he told me, Misha, look, I don't feel anymore. I can't feel, because before I could actually touch what I was cutting. Now I just don't feel it anymore. There's scalpel and there's the image, and that's about it. So my Jason Center for Robotic Research, in a group called Hammer, led by Hong Bin, they developed a totally new set of sensor, very small miniature, non-metallic sensor, which was embedded into the scalpel. And then we used on the other end a haptic glove, and then putting both together allows essentially the doctors to feel in the future when they're doing the surgery. The second thing we did is we questioned whether the Procca actually needs to travel to the hospital. He commutes every day an hour and a half one way, so 3 hours in total. So one of our best doctors in the world commutes 3 hours every day. Why not have him operate from a North London hospital where he lives into a South London hospital where the patients are? So he can literally be in a hospital nearby his home, have an end-to-end sliced architecture to the patient, and do the operation. The patient is with medical help. There are nurses there. There are also doctors there, but they just don't have that high-end skill which Procca has. So we see a world where with a proper end-to-end slicing, you could have any doctor operate any patient anywhere in the world. We do not need them anymore to fly there or the patients to fly to the doctor. That's the type of democratization we're looking at. Another example, which has been covered by the Financial Times, is about remote colonoscopy. And again, that's an exciting project we do with the Center for Robotic Research here at King's. So it turns out the colon cancer detection rate in rural China is very poor. It's very poor not because they don't have good doctors, but because the good doctors want to live in the capitals. They want to live in Beijing and Shanghai and Guangzhou. And that happens to every country, whether that's the United States, United Kingdom, India, China, Australia, any country has that problem. So we thought, hey, why don't we construct something very cheap, which will be in the rural outlets, which is a very soft robotic device which has no metallic elements in there, so it's fully controllable soft robot developed by the Robotics Center, and we connect it with an ultra low latency 5G slice into the best hospitals in the country, and then we give the doctors a fully immersive environment so they can in situ inspect essentially the patient. And so the patient, rather than getting very poor advice and being sent from hospital to hospital in the rural areas until it's too late, gets the world-class, kind of inspection straight from the best doctors in the capitals, in the big cities, and therefore gets the right advice at the right time. And we hope to save a lot of lives with that type of technology. Let's change gear now and look in the arts world. So with Ericsson, we did an exciting project in the Hermitage, which is one of the leading arts institutions in the world. It's a place in St. Petersburg, and it is home to one of the most well-known restaurateurs in the world. And we offered him the ability to maintain artwork remotely. Of course, there was resistance. He thought that's not possible. But then he got curious because, of course, it would be great to maintain artwork in remote places where he can't travel to. Think of war-torn areas like, Iraq and Syria, where we have a lot of the ancient artworks, but we can't really maintain that properly. So we gave him this ability to use his skills with a remote robotic handset here to essentially maintain the artwork. And he loved it. He had this full immersion. He had this very low latency, this feeling of immediacy, and he could really go about the restoration of the artwork. Another exciting use case is all around DJing.
The idea is to create an EDJ experience. Imagine a DJ DJing in Los Angeles, and that person is then being transmitted in real time to another club.
So you see here, Peter Gold, it's a #2 DJ in the world, arguably. #1 probably is deadmau5. You may have different philosophies. So Peter Gold was DJing in Avalon, a big club in Los Angeles, and we beamed him into an adjacent club via hologram here in off West Hollywood. And he would essentially also get a real-time picture of the dancing crowd in the other club. And the idea is to give him the ability to adapt his music, his BPMs, his beats per minute, depending on two crowds: the crowd he sees in front of him in the Avalon Club, as well as the crowd which has been brought to him by an ultra low latency 5G slice. And getting this up and going, I realized, actually we're doing something which goes well beyond, this holographic world, or the augmented reality world, or the virtual reality world. We are actually bringing environments together. So in virtual reality, you're being brought into a new reality, or the reality is being brought to you. And what we're doing is we're bringing these realities together. We're creating what we call synchronized reality. So that's a term we came up with, Samantha from Hemingway in Los Angeles, and myself. So she comes in from the arts world, I come in from the tech world, and we realized, the next big thing powered by 5G will be synchronized reality. And let's come back to our use case here with my daughter, where I was playing in Berlin. She was singing in London. And, we got a delay of 20 milliseconds between both. So that was a remarkable achievement. And what we really want to do with that today is to commercialize it. Imagine your most favorite music band being split up. Not literally split up, but physically split up. And they're announcing the concert in two different places at exactly the same time. Everybody freaks out, and then you use an ultra low latency slice to connect both the stage and the audiences, and you have I think a very fascinating experience in the future where maybe different music bands in the world will be essentially making a truly global concert. So that's really what the future holds for us, and please do remember that we are talking about a commodity internet. 5G will be commodity tomorrow. So today it's very expensive, very luxurious, it's very beta, but tomorrow it will be a commodity internet. So prepare for a very, very exciting future. And where's that future going? Well, my vision is to design a totally new internet. If you think about it, we have designed 3 internets until today. We have designed, the fixed internet, and we connected every single computer. After that, we designed the mobile internet. We connected every single mobile phone, going from 2G, 3G, 4G, and now 5G. And after that, we developed, the things internet, or the internet of things as we call it, connecting all sensors and actuators. And 4 years back, I asked, what's the next internet? What's the next thing we're gonna connect? And the inspirations to that answer came through a crisis, actually. So it was the height of the Ebola crisis, and King's College London was leading the UK response in Sierra Leone. And our doctors were reporting that we were lacking skills. They're saying we're lacking skills. Nobody wants to fly down there because they're scared to get infected. And I thought, hey, why don't we combine, our best robotic edge equipment designs with our best networks? Put a little bit of artificial intelligence in there because it's a very hip topic at the moment, and design something which would allow us to virtualize medical skills. And I thought, once this is up and running, I could not only apply it for doctors, I could apply it in the music world. I could teach people how to play the piano. People could teach me how to paint because I'm very lousy at that. Or we could have our best engineers maintain cars and engines. So I just realized, internet like this would democratize labor the very same way as it would the internet has democratized knowledge and information today, right? And I gave it a name, and I called it the Internet of Skills. And 4 years back, everybody was kind of smiling at me. But God was very quick these days, as they say, and we have come a long way, and you have seen it. We have done a lot of the Internet of Skills examples in the music, in the health world, sports world, etc., etc. And I'm very excited about this because I feel this enables a transformation from today's vision on an Industry 4.0 to tomorrow's world of Human 4.0, where you start empowering humans rather than machines. And, I think that is a really, really exciting future.
Well, ladies and gentlemen, we've come to the very end of the course. Thank you for being with me through the entire course, for being such wonderful listeners, and get in touch with me whenever you can. I hope you have learned something substantial about the functioning of this wonderful next generation public internet technology. If you want something more deep, get in touch with us and we'll tell you really how to get really to a pro level in 5G. Otherwise, enjoy and wait for this little 5G logo to appear on your mobile phone. Thank you.